Hello everybody, in this video we're going to talk about subtracting rational expressions without common denominators. And honestly, probably the most challenging thing about all this is factoring these denominators to get that least common denominator. So I'm going to go through it slowly, follow along, watch it a few times if you need to just to go back. But essentially, it's the same process we would do when subtracting fractions without common denominators. So first things we need to do is factor each of these denominators. Now, these look pretty intimidating, but let me try to kind of break it down a little bit so it's not so challenging. Many of you might want to try to factor this by maybe multiplying the 7 over here with the negative 48, and then doing that method where you then try to find the values of c to add up to b. But that gets to be tough because right off the bat, I know 7 times negative 48 is going to be more than 300. Then we got to find factors of that number to add up to negative 34. Might be kind of challenging. So let's just start by making our two binomials and kind of talking through this and thinking through this factoring. So first of all, to get our x squared in the front, well, we know it has to be x in x, right? And then how do we get 7? Well, 7 is a prime number. There's only two numbers that multiply to give us 7. That's 7 and 1. So we know one of these has to be 7x and the other one has to be 1x. So I'm not going to put the 1 in there because that's unnecessary. Then we have to think, well, now we need two numbers that multiply to give us negative 48. But then when we multiply those numbers with 7 and 1, they have to add up to negative 34. So we can kind of play around with these numbers a little bit. So if we just think about factors of negative 48, well, there's 12 and 4. We could do 1 and 48. There's 6 and 8. Can you think of any others? Maybe 24 and 2. Okay, let's just start there. So looking at these, can we make a combination with 7 and 1 where they add up to negative 34? Well, looking at 12 and 4, if I have 12 here and if I have 12 here, we're going to multiply it by 7, which gives us, 84. And then can we add that with 4 somehow? No, that doesn't work. That won't get us to negative 34. How about flipped around? If this was 4 over here, that would give us 28 and 12. So 28 and 12, though, we can't get to negative 34 like that. So that doesn't work. How about 1 and 48? Well, that probably wouldn't work either because we're going to have 48 here. 48 times 7 is a big number. If we flipped it around over here, 48, we got 1 times 7. That's not going to work either because we're still not going to get down there. How about 6 and 8? Well, if we did 8 times 7, that's 56. And then if with 6, that doesn't work. What about with 6? 6 and 7 is 42. And then if we have 8 here, hey, we can get to negative 34. So if we have the 6 over here and we have the 8 here, right? If we do 7 times 6, that's 42. But then we got to get to negative 34. So we need a negative 42 plus an 8. So our 8 needs to be positive and our 6 needs to be negative. So I know that was kind of a lot to go through and a lot to process, but that is kind of a way just to think through the factoring and try to figure out what two binomials can multiply together to give us this expression. So looking at the other one, I'm going to delete these factors here. So this one is now completely factored. If you want to multiply that out just to check it out, you can. And then to factor this one over here, again, the factoring might be rather challenging. But if we look at this, I shouldn't have deleted those factors because we're going to need them for this one as well. Again, to get over here, there's only one way to get 5x squared. It's 5x times x. 5 is a prime number, so we can only multiply 5 times 1. And then looking at negative 48, again, we're going to try to find factors of negative 48 that when we multiply them together give us negative 48, but when we multiply those numbers with 5 and 1 give us negative 22. So if we think through it a little bit, we'll find that actually 8 and 6 work as well. If the 8 is here and the 6 is here, all right, we need a negative 30 plus 8 to give us the negative 22. All right, so those factored. And then from here, to get our LCD, we are just going to multiply our common factors or our unique factors together. So we have 7x plus 8. Let's get rid of that. There isn't a 7x plus 8 over here, so we don't need it. We have an x minus 6 and an x minus 6. Remember, those are both to the first power, so we just need to use the one with the bigger, and they're the same, so we can really use either one. So we'll get rid of those. Don't need to repeat them. And then finally, we have 5x plus 8. So here is our least common denominator. So if we rewrite both of these expressions with the least common denominator, we have 7x plus 8 times x minus 6 times 5x plus 8. And that is minus, again, the same common denominator, 7x plus 8 times x minus 6 times 5x plus 8. All right. So from here, we need to decide what did we multiply our denominators by to give us the LCD? Because whatever we multiply the bottom by, we need to multiply the top by. Well, our original is 7x plus 8 times x minus 6. And so we multiplied in this 5x plus 8. So we need to multiply the numerator by that as well. So 5x plus 8. Same with this one over here. What did we add in, or excuse me, what did we multiply into this denominator to get the LCD? Well, the original is 5x plus 8 times x minus 6. So we multiplied in this 7x plus 8 in the denominator, and we have to do it the same in the numerator to keep these expressions equivalent. So it's going to be the 3x times 7x plus 8, because that is our new factor in our denominator. From here, we can distribute this on both of them. All right, so it gives us 2x times 5x is 10x squared. And then 2 times 8, of course, is 16x. And then from here, let's distribute this first. But remember, we also need the negative to go into both terms. So it's going to be a minus 3x times 7x is 21x squared. And then negative 3x times 8 gives us a negative 24x. All right, don't forget to distribute that negative into both terms as well, because we are subtracting both. So even if you multiplied this out first to give you 21x squared plus 24, remember you are subtracting both, so it gives us negative 21x squared minus 24x. All right. Oof, deep breath. This is a big one. All right, denominator stays the same. Okay, that's our least common denominator, just stays the same. And now we can combine like terms. So we have 10x squared minus 21x squared. That gives us negative 11x squared. We have 16x minus 24x. That gives us negative 8x. Again, over our least common denominator, which is 7x plus 8 times x minus 6 times 5x plus 8. And looking at this, we can factor. We can actually take out, let's take out a negative x from both terms. So if we take out a negative x, that leaves us with 11x and then plus 8, right? And that is over our least common denominator, 7x plus 8 over x minus 6 times 5x plus 8. Whew. That is a lot to go through. And so look, are there any final factors we can simplify? And there are not. We can't factor this anymore. So here is our final answer after subtracting these two rational expressions without common denominators.